Physics program from School of Physics. I contributed in this video as a scriptwriter. Hope everyone will enjoy our video and learn something new from our video.
Hi everyone, my name is Chye Yi Heng from School of Physics, majoring in Applied Physics. In this video, I contributed as an editor. Hope you all enjoy watching our video.
Hello, my name is Xin Wei. I'm a first-year student studying Applied Physics. So in this video, I'm going to talk about MagLev wind turbines. MagLev, which is short for magnetic levitation, is a system where a set of magnets are used to make an object float above a surface. This removes the friction between the object and the surface, thus allowing the object to move along the surface with minimal resistance. A famous example of this is the MagLev train, which is one of the fastest trains in the world. And the wind turbine is what's used to harness wind energy. There are two types of wind turbines, the vertical axis and the horizontal axis. Both of these use the same concept, where a rotor is connected to a generator, and when the wind spins the rotor, it converts the kinetic energy from the wind into electricity. So how do magnetic levitation and wind turbines come together? I'll come back to that later. So there is one major problem with conventional wind turbines, that is friction. A lot of energy is lost through friction when the wind turbine spins. Not only is this inefficient in terms of energy conversion, friction also causes wear and tear on the turbine. A solution to this problem is magnetic levitation. So we know that the magnitude of friction is directly proportional to the force acting on the surface. So if you use magnets to support the heavy turbine like this, there will be no weight acting on the surface, thus greatly reducing the friction. Here's a simple example of how it looks like. So a set of magnets is installed on the platform that supports the wind turbine. And another set of magnets is installed below the wind turbine, such that when the wind turbine is mounted onto the platform, there's a repelling force between the two sets of opposing magnets that support the weight of the turbine. You can see that the turbine is not in contact with the platform at all. This means that there's no friction. Without the friction between the platform and the wind turbine, even without strong winds, the wind turbine can spin very quickly and generate electricity. So, as you may have noticed, the magnets were not connected to any electrical sources. This is because MagLev wind turbines do not use electromagnets. Instead, they use a type of magnet called neodymium magnets, which is a type of rare earth magnet and is currently the strongest permanent magnet in the world. So, all of this sounds great, but why aren't we seeing these MagLev wind turbines? As mentioned earlier, instead of electromagnets, MagLev wind turbines use neodymium magnets, which are a type of permanent magnets. Now, permanent magnets are not as strong as electromagnets. This means that the size and weight of the turbine is very limited. And of course, we cannot use electromagnets because there's no point in designing an electricity generator that uses electricity itself. That is why there are currently no large model prototypes for MagLev wind turbines. And on top of that, neodymium is a rare metal, which means that neodymium magnets are rather expensive. So if we were to mass produce MagLev wind turbines that use neodymium magnets, the cost production will be very high. That being said, one large MagLev wind turbine is estimated to be able to generate up to 1 gigawatt of clean power. That is enough to supply electricity to 750,000 homes. Imagine if that were to become a reality. MagLev wind turbines have a lot of potential. In the future, with more advanced technology, we may be able to fully harness wind energy and revolutionize power generation. That is all for my presentation. Thank you.